All right, folks. Today what we're going to do is continue in our series of learning C++. And what I'd like to introduce you to today is learning C++ functions, functionality that's built into C++, functions that you can use that perhaps solve more complex problems than you're ready to implement yourself at this point. They include a huge variety of things, and we're just going to touch on a few things. The first thing you need in order to use some of these functions is to learn how you communicate with those libraries. In order to do that, I'm going to show you a handy-dandy reference that I like to use called cplus.com. Here you can see I have cplus.com referencing CMath. CMath is one of these libraries that we're going to use. CMath gives us access to a host of mathematical functions. You can see there's sine, cosine, trigonometric functions here, exponential functions, some rounding and floors and absolute values, and a whole list of things here. If you're curious about all of the things that you might possibly run into, then feel free to tab on over to cplus.com, CMath, and check that out. The cplus.com reference can be really useful as you continue in programming to get references to various things and otherwise be able to look something up. It's not quite as useful as a learning tool. There is a learning C++ website that's useful for that. Hopefully these tutorials are helping you out in that way. In any case, what I want to do first is show you how you can plug into using some of those C mathematical functions, demonstrate a couple of function calls where we actually use the functions, and move on from there. If you're going to use any of the functionality in CMath, then it would be appropriate to include CMath at the top. This does a variety of things, but largely you can think of it as granting you access to that suite of mathematical functions that are available. One of the things that you saw that's available is perhaps a cosine function. This thing is done in radians, and you can pass a literal numeric value to the cosine function, but you could also pass a variable. So if you wanted the user to give you some value and then figure out what the cosine of that value and assign it to another variable, you can do that. You can use these things, the result of the function you can use anywhere that you could use the type of that result of that function. So cosine is going to return a double, and thus you can use the result anywhere you could use any other double. So cosine also takes in a double, which means anything that evaluates to a double you can pass in there. So I could pass in x, but I could also pass in x plus 3.14 if I wanted to, x plus pi. Anything that evaluates to a double can be pushed into its parameter list because it expects a double. Anything that can use a double can be used as a value as a result of the cosine of x. Generally, when talking about functions, this seems very reasonable to new programmers. There isn't really anything new here. We can output some of these values here and demo this real quick. But largely, this isn't anything new. It feels normal. Oh, I have a build error. Isn't that nice? Anybody see my build error? Oh, let's find that out. This is actually useful. Uninitialize local variable x. So I use x before I initialize it. I meant to get user input for this real quick. And so let me go ahead and squish this back down so that, oh no, so that you don't have to see it. All right, let's try that again. Anyway, you can use the result of this function any way that you would use a double. You can use the input any way that you could compute a double value. So you can see cosine of 0 is 1. Hopefully that's as you expected if you know a little bit of trig. If I pass in a value like 3.141 here, the cosine of pi, or close to pi, is -1. This is good, right? This is exactly what we would expect to see from this stuff. If your function has multiple inputs, multiple parameters, then they come as a comma-separated list. So for example, if I wanted to find the power of 3 to the 4, then I can pass those two parameters to the power function as a comma-separated list. And you can see here it's returning a double, and it's taking in 2 integers in this case. It turns out that there are multiple versions of POW that handle kind of a variety of inputs. So you could see that I did it with a double and an int and an int and an int, and all of those just work just fine. Did I have another error here? Or did I just, oh no, it's on the other screen. All right, here we go. Here we go. So I'll go ahead and output something like 1.5 for cosine. I get something pretty close to 0. And then, of course, 3 to the 4th is 81. POW is capable of handling kind of strange powers, which might not normally come up in your algebra class. It's capable of handling those. And so you can do something like the power of 3 to the 4.32. And so hopefully a number like 115 makes a little bit of sense. Anyway, that's how you do it. One other thing I would like to mention is you can use these function prototypes to kind of figure out what's expected from your functions. The C++ Ccom site is a little bit slow at the moment, but this here is called the function prototype, and it describes exactly what's expected into the function and what comes out of the function. So cos is the function name. That's what you call the function with. That's what you name the function. The stuff inside parentheses are the input parameters. In this case, cosine only has one input parameter, and that it says that it expects a double. And then the things that comes before the function name is often called the return type. That's kind of what's expected out of the function. That's what's coming out. And in this case, cosine expects to return a double. If we go back and we look at, say, like the power function, let me see if I can find it here. Here we go. Raise a number to a power. You can see here that the base and the exponent are both expected to be doubles, and it returns a double. Of course, Visual Studio gives us access to kind of a suite of templated versions of power that handle things other than just doubles and ints and stuff like that. Passing it in as a double is okay because it will be upcast to a double, so that's fine. You might find that in certain situations, using one of these functions that's meant for doubles doesn't quite work out, and instead you should pay attention to whether it's an integer function or a float function. The most common version of that is absolute value that has a different version for floats than it does for ints. This does sometimes cause problems. So you can see there's an abs and an fabs here. Obviously, or perhaps, hopefully obviously, the fabs is for floating point absolute values and abs is for integer absolute values. All right. So this is the basic idea. One thing that I do like to do when I first introduce libraries and include files and functions is show folks how to do randomness. You really kind of want a couple of things for randomness. You're going to want the C standard lib here, and you want the C time lib here. I'm just going to show you how I would actually use those things real quick. So I'm going to pound include C time, and I'm going to pound include C standard lib. But you can always go to those resources and check those out. The way that I would use those is, first I would seed the random number generator based on the time. If you don't understand what seeds are, that's okay. Go look it up, go learn. It's definitely within scope of a video, but I think it would make this video a little too long. Anyway, this is going to seed it differently every time I run the program. You might sometimes see this written as sran time null, but null is simply 0, and so that's why it looks like this. In order to get a random number, you call a function called rand, and that generates a number between 0 and a maximum integer. So if you wanted to do something like a d6 dice roll, then what you would do is get a number between 0 and the maximum integer, and then you would mod that by 6, which gives you a number between 0 and 5. Now this percent sign is a modulus symbol, which basically is the remainder function. It will take whatever integer is generated, divide it by 6, and the result of rand mod 6 is the remainder. And then, so that gives us a number between 0 and 5, and then we add 1 to that to get a number between 1 and 6. So this generates a random number from 1 to 6. So if you're like me, and you like games, and you like games with randomness, then chances are you'll want to use a rand function like this to generate a variety of things. If you need floating point random values, then you can always take rand and divide it by rand max. Again, refer to the documentation if you'd like to learn more about that. One other thing that I would like to point out about functions is that some objects actually have functionality attached to them. Cn is one of those objects, and so one thing that happens is if you type in a character instead of a double here, well, Cn enters a failure state, and you can actually test that failure state.
So you can ask if cin has failed by calling cin.fail. This uses something called a dot operator. And in this case, it means that I didn't actually get an x in, even though cin tried to read in an x. Maybe the user typed a character or something like that. In situations like that, maybe you want to initialize x, or maybe you want to get more input or something like that. You can even ignore some input for some number. Like, I don't know, maybe you want to ignore 128 characters. Maybe you want to ignore 128 characters until you see a new line or something like this. You'd have to go out and look up these functionalities to understand why and how this works. But I did want to actually at least show you that it does work. And so if I come in here and I run this program, here's my window, okay, and I type in the character A here, well, it then assigns x to be 0, which is fine, and does this. If I assign this to something else, then it would assign there too. And the great thing about this is that even though cin has failed, I can still kind of do some default things. If your cin has failed and you kind of want to use it again, then you can use something called cin.clear to clear the failure flag. And this can be really, really useful to build more robust read integer functions. So instead of just doing a cin to x for the double here, you might do a cin to x, and if cin fails, then you might do something different to try to recover from that failure. So you can make your programs a little more robust in that way. Again, going into all the details of these different pieces of functionality is a little bit beyond the scope of a single video. Go and look them up. Check them out on C++.com. Read their stuff. Look at their sample code. See what it does. And the same goes for some of this seeding and randomness stuff. Learning by documentation is a little bit hard, so I would recommend you write examples, try things out, see what happens. All right, I think that is enough for this video. We've learned about what these pound includes really do, which is add functionality to do different functions. We've tried a few functions. We've looked at some function prototypes. Hopefully you can go out and use some of these things. All right, that's it for today. Bye.